Thank you for joining this lesson. Number 14, we are told in part A to distinguish between solids and liquids, or the solid and liquid states of matter in terms of intermolecular forces. So the distinction between solids and liquids in terms of intermolecular forces is that solids have stronger or greater intermolecular forces compared to liquids. Therefore, the intermolecular forces, we know that they are called cohesive forces, to be specific. Therefore, we say that solids have greater intermolecular forces. Intermolecular forces compared to or than liquids. This is the reason why solids do not diffuse easily, but liquids can move from one place to another. Rather, the molecules of liquids can move freely because the intermolecular forces attracting them to one another are weak. Part B, in an experiment to estimate the diameter of an oil molecule, an oil drop of diameter 0.05, this should be centimeters, sorry for the typing error, spreads over a circular patch whose diameter is 20 centimeters. Then we are told to determine part 1, the volume of the oil drop. Remember, the oil drop is assumed to be a perfect sphere. Therefore, if a volume for a spherical object is being determined, then we apply the formula 4 out of 3 pi r cubed. So 4 out of 3 pi r, which is 0.05 cubed. But now before we cube, we should know that this one has been given as diameter. Therefore, we make it radius by dividing it with 2. And now we cube. It. So let's look at the answer to this when we use the calculator. Remember, we have 4 out of 3 times 22 out of 7. Then we're going to take 0.025. So we multiply with 0. Okay, we can open brackets because we're going to cube a 0.025 instead of 0.5. Then we raise it to power 3. This is going to give us 6.548 times 10 raised to negative 5 centimeters cubed. So that is the volume, applying the formula. Remember to subscribe to this channel as we continue reading together, and you also share with friends. The area of the patch covered by the oil. Remember, when the drop is spreading, it spreads to a circular patch. Therefore, now that a circular patch has been formed, we can get its area. So area of a circular patch will be pi r squared. So pi times r, which is a 20 centimeters diameter. So the r is going to be 10 squared. So we're going to have a 22 out of 7 multiplied by 100. And this will give us 314.29. We're going to have this one as a square centimeters, now that it is area. Then finally, we are told in the same question to determine the diameter of the oil molecule. Another name instead of diameter, you could have been told to determine the size of the oil molecule, or simply the thickness of the oil molecule. The thickness is given by volume divided by area. This is owing to the fact that the volume of the patch will be equal to the volume of the original drop, which means now that we have area for the patch, then when we multiply the patch with the small thickness of the molecule, we're going to get the same volume. So to remain with T, which is the thickness, or rather the diameter or the size of the molecule, then we will need the volume, which is already known, and we divide with area of the patch. This will give us the thickness of the molecule. Therefore, we shall have 6.548 times 10 power negative 5 divided by 314.29. So let me use my calc to operate the same. When we divide the volume with 314.29, I'm getting 2.083 times 10 to the power of negative 7 centimeters. So if the diameter has been given in centimeters as that, then in SI unit we will divide by 100 and we will have 2.083 times 10 to the power of negative 9 meters. That is when we have made it the SI unit. Part 2. Okay, part C, Roman 1. Any assumptions made in Roman B or B Roman 3 above. So the assumptions made in this experiment, the oil drop experiment of determining the thickness of a molecule, are several. And we have one that the original oil drop is a perfect sphere. That is one of the assumptions we make. We also assume that when the drop is let to spread, then it spreads until it is 1 molecule thick. Therefore, the patch is 1 molecule thick. Again, the patch is assumed to be cylindrical, because we are assuming that the patch spreads to a circular patch, then with a small thickness, and that's why we treat it as a cylinder, which is having some cross section and a very little thickness equivalent to 1 molecule. So thank you for following, subscribe and share.